Hi everyone, my name is Suja and I'm from third year EPH. Today I'm going to speak on the topic finding the two's complement of an 8-bit number. Now let's look at the process. So there are basically two steps in finding the two's complement. First, we have to find the ones complement of the given number and then add 1 to it. Let me explain with an example. Let's take a number 19 and its binary form is 01011010. So first step is finding its ones complement, which is converting the ones to zeros and zeros to one. So let us do it. So here it becomes 1 0, 1 0, 0 1, 0 1. So this is the ones complement of the number 19. And now we should add 1 to it. Here 1 and 1 adds to give 0 with a carry of 1. Here as you can see it's 0 and this 1 is added with 0 to give 1. So this is the final answer, that is the two's complement, which its decimal form is 166. So as we have seen the steps, let's move to the code. So this is the code which we use to find the two's complement. So let us say the number 19 is loaded to 7000 hex location, and from here we load it into the accumulator. In the accumulator where all the process of finding its complement and adding 1 takes place. So first, as you can see, this is the instruction LDA, which means load to accumulator. We load the number to the accumulator, and then as we know, the first step was ones complement. We can find the ones complement of the number using the instruction C and A, which means complement of accumulator. Here we can find the ones complement. Then the second step, as we all saw, was adding 1 to its complement. We can do that using the instruction INR-A, which means increment by 1. The number in the accumulator is increased by 1. Or we can also use the instruction ADI, add immediately 01 hex, adding 1 to the accumulator. So after this two process, we can get the two's complement, which is in the accumulator. Now we can load the answer from the accumulator to the desirable location. Now here I have given 7002 hex, so we can use the instruction STA, store accumulator, to store the answer. And then finally we hold the process. Now let's see the code being run in GNU Simulator. So as you all can see, I have already given 90 to the location 7000. So from here, the first step is to load it into the accumulator. As you can see, after loading it to the accumulator, the register A becomes 5A. 5A is basically 90. Here you can see I have converted 90 into hex form, that is 5A. So when we use the load operation, the number from 7000 gets loaded to the register A, in which all the process that we are going to do happens. So the next step is CMA, which is finding the complement of the accumulator. And here we can see it was previously 5A. Now it has become A5, which is basically the complement. Now let us move on to the next step, which is increment. Increase it by 1. Here, as you can see, the 5A, which became A5, is now A6 because we have increased it by 1. So, and finally, we store it here in 7002 hex using the operation STA. Now, when we look at this address 7002, and see the number 166, which we previously got using the steps. So that's it for this finding two's complement, and thank you.